my name is Paul Carroll and I'm a driver trainer based in Adelaide.
And I'm Mark Constable, I'm also a driver based in Adelaide.
In this video, Mark and I will explain and demonstrate some of the operating features of the NR class locomotive.
We'll also show you some basic train handling techniques which you should use across the National Rail network.
So let's start by preparing NR 108. Come on, Mark.
Sure, Paul.
Before boarding the locomotive, there are a number of checks that we need to make. Firstly, close the battery isolating switch and communication isolation switches. Then as you walk around the loco, make sure all cutout cocks are in the correct position. Check that there are no broken, dragging or worn parts, particularly in the brake rigging. Make sure the sandpipes and the millipede removal lines are correctly aligned with the head of the rail. This is particularly important for trains like the one we're working today that are operating through the Adelaide Hills because of the problems that are experienced with millipedes collecting on the head of the rail. You should then check the level of sand in the sandboxes. Once inside the loco cab, we need to check that the spring park brake is applied, the engine control switch is in start, and that all circuit breakers on the driver's control panel are on. Check the logbook for any faults or repairs that may be required. Now check that the reverser is in neutral, the throttle is in idle, the generator field switch is off and the engine run switch is on. Now check that the brake handles and the emergency dump valve are in the correct positions. On the overhead console, check that all switches are in the required position. For our next set of checks, we need to go outside again. It's now time to check the fluid levels on the locomotive. Firstly, the lube oil level. When the diesel engine is shut down, the oil level can be as much as 25 millimetres above the full mark. The next check is the coolant level in the header tank sight glass. Let's now check the level of oil in the compressor. The engine is started by moving the engine start switch to the prime position and waiting until the fuel pressure light is extinguished. Then move the switch to the engine start position until the diesel engine starts. Now that the diesel engine is started, we can check the IFD screen and the DID panel. The DID panel will now show the initial startup message of load limited. This indicates the locomotive is in a reduced horsepower mode, waiting for the loco engine temperature to reach 60 degrees Celsius. When this temperature is reached, the DID panel should show the summary message ready. This indicates that all systems are running and the locomotive is ready to function normally. We can now set the variable horsepower mode on this locomotive using the DID panel. For today's train load, I will need to set the horsepower mode in notch 7. While at the DID panel, go to level 2 and check the history log and take the parameter details. To enter level 2, enter access code 455466. The next screen will ask you to select which level. Press the alphanumeric 2 followed by the F5 Do It key. Next, enter the password, which is F5, followed by the alphanumeric 2. Then press enter and the default level 2 screen will be displayed. Then press F5 etc., F1 monitor and F5 specific, and then key in the required parameter number. You should record the kilowatt hours in power and dynamic braking using the parameters 1054 and 1083 for the purpose of monitoring fuel consumption performance. The preparation of the locomotive is now completed by checking the operation of the sanding equipment and the fuel level. When checking the fuel level, it is important to consider the minimum amount that will be required for the corridor you will be operating on. Checking the air brake setup is done from the operator function screen. If the current setup needs to be changed, this is done by pressing the F2 key. The air brake setup screen will then be displayed. The F1 chain setup key is then pressed to display the 321 setup screen, enabling the driver to change the brake setup using the F3 and F4 keys. The consist size can also be changed using the F5 or F6 keys. Once you have set the brakes up in the desired mode, simply press the F7 key to save the setup. In the next screen, you will be asked if the setup displayed is the one you wish to change to. If you are sure, press the F1 Do It key to save the setup. Press the F8 Exit key, back to the function screen. When preparing any locomotive, it is important to check the setting of the vigilance before conducting the air brake test. To do this, the function verification test screen must be accessed from the operator function screen by pressing the F6 key. Then press the F4 alerter timing key. Then select the required rail authority timing, in this case cycle C, by pressing the F3 key. Then press the F8 key to exit. The final task in preparing this locomotive is to test the driver's brake valve. Before doing this, I make sure the park brake is applied, the reverser is in gear, and full air pressures are displayed on the screen. I then make sure both brake handles are in the release position. The first part of the test is to open the emergency brake valve. Mark then checks that the brake pipe pressure falls to 0, the brake cylinder pressure rises, and the Loco brake and PKS indicator lights are illuminated. Now close the valve and place the automatic brake valve in the emergency position and wait for 60 seconds to reclaim full air pressures. Reclaiming the air in this way is done a number of times during the locomotive air brake test. Then check that the brake pipe pressure returns to 500 kilopascals and the PKS indicator light is extinguished. After the preset vigilance timing has elapsed, Mark can allow the vigilance to trip and check that the brake pipe pressure falls to 0. Once the air has been reclaimed, the automatic portion of the brake valve can be checked. The automatic brake valve handle is now moved into each position while a corresponding fall in brake pipe pressure is observed. Firstly, the 50 kilopascal or minimum reduction position, then the 70 kilopascal reduction position, and finally the 150 kilopascal position. The brake cylinder pressure should also increase. The bail-off feature can now be tested by depressing the independent brake valve handle and checking that the brake cylinder pressure falls to zero. The automatic brake valve can now be placed in the emergency position to check that the brake pipe pressure falls quickly to zero, the brake cylinder pressure rises, and the PKS and Loco brake indicators are illuminated. The automatic brake valve handle can now be placed into the release position. Check that the brake pipe pressure rises to 500 kilopascals, the brake cylinder pressure falls to zero, and the PKS indicator is extinguished. The independent brake can now be checked by gradually applying the independent brake and observing the pressure rise to approximately 560 kilopascals. Now release the spring park brake and observe that the brake cylinder pressure falls to approximately 450 kilopascals. We now need to reapply the spring park brake and see that the brake cylinder pressure once again increases. Now return the independent handle to the release position. The next test is the brake pipe leakage test. The first thing to do is make sure the maintain, non-maintain switch is in the cut out or non-maintain position. Then place the automatic brake in the full service position, thereby reducing the brake pipe to 350 kilopascals. Wait until both the brake pipe and equalising reservoir pressures equalise. Now observe the IFD screen for 1 minute and check that the brake pipe leakage does not exceed 15 kilopascals or the brake pipe pressure does not increase. Also check that the brake cylinder leakage does not exceed 15 kilopascals. If the test is satisfactory, place the automatic brake valve into the release position and place the maintain, non-maintain switch in the in or maintain position. The final test is the dynamic brake interlock. To do this, place the automatic brake valve handle in the full service position once again, keeping the independent in release. Engage dynamic and check that the brake cylinder pressure falls to zero. Now make an emergency application and see that it overrides the interlock and that the independent pressure increases and the PKS indicator is illuminated. The test is now complete and the handles can be returned to their correct positions and the spring park brake released. Mark and I will now use the pre-departure checklist form to check things like the train consist, if there are any dangerous goods in the consist, the marshalling of lightly loaded wagons, train inspection certificates including retention tests, and other track authority notices that may be relevant for this journey. Mark, have you calculated the horsepower per tonnes and the tonnes per operative brake bogie? Your off-job trainer will be able to show you the method used to calculate these horsepower and tonnage figures.
Examiner to the driver of 108, you're receiving, over.
Driver of NR 108 receiving, train examiner, over.
Mark begins the train brake examination by placing the maintaining feature in the cutout position for the leakage test. He then places the automatic brake handle into the service zone and reduces the brake pipe pressure by 100 kilopascals. When the pressures have equalised, Mark observes the brake pipe pressure for 1 minute and notes that it does not fall by more than 35 kilopascals.
AFT examiner to the driver of NR 108. Are you receiving? Over.
NR 108 receiving, train examiner.
108, would you like to give us a release please, and also a leakage? Over.
Releasing the brakes on NR 108 and the leakage was 7 kPa. Over.
Message received. Thank you.
When the train examiner completes his examination and returns to the locomotive, he hands the brake test certificate to Mark for him to check and sign. It is important to remember that during roll-by inspections, whether they be when leaving the terminal or while en route, the ETM must be sighted and operating to ensure the train is complete.
AFT examiner to the driver of 108. Receiving, over.
NR 108 receiving, wagon maintainer.
The roll-by was okay. Catch later on.
Righto, thanks for that.
As the train departs, the distance counter can be used to let the driver know when the train is clear of the terminal. This feature can also be used, of course, when entering or departing crossing loops, and to tell the driver when the train has passed completely over a speed restriction. The distance counter can only be accessed from the gauge screen.
Our train is 430 metres long. It's going to tell me when I'm clear of the terminal limits, letting me know that I can increase the speed. I've now stopped the counter, I'm clear of the terminal, so I can now pick up the speed. I will now reset the counter, ready for my next reading.
Mark is now applying the automatic brake. This is the first opportunity he has had to make a running application and release of the train brake after departing the Adelaide Freight Terminal. This procedure gives him an indication of the braking capacity of this particular train, in addition to the calculated tonnes per operative brake, remembering of course that all trains react differently depending on the varying conditions. One of the most important features of the NR locomotive is the fuel miser feature. Mark will now demonstrate this feature using the preferred method.
Right, I want to take that back loco offline. I want to go into the consist monitor, so I'll press F4. And now I shall limit the back loco NR51 which is taking it offline. To bring it back online, I'll press F2. Now the back loco's online.
Another feature of the NR locomotive is the fuel monitor screen. I can access this screen from the function screen by pressing F6. I then press F3, fuel monitor, and now displayed is the locomotive fuel monitor screen. From this screen I can tell the kilometres travelled since the last reset, the litres consumed since the last reset, and the litres per kilometre consumed since the last reset. We are able to check the average speed of the locomotive by using the measured kilometre screen. We do this by pressing the F6 key from the function screen. We then press F2, measured kilometre, and when the locomotive draws level with a kilometre post, we simply press the F1 start kilometre key, and during the next kilometre the computer works out the average speed of the locomotive. When the locomotive draws level with the next kilometre peg, simply press the F2 key to stop the counter. Our average speed for that kilometre was 50.6 kilometres per hour. When stopping a train on a heavy gradient, sand should be applied through the use of the manual sand facility as the train is slowing to a stop. Enough sand only needs to be applied so that the locomotives are standing on sand when they have stopped. This will assist in providing starting adhesion upon departure. When the train is ready to depart, the locomotive is to have the independent brake fully applied. The throttle is then advanced to notch 6 position. Traction motor amperage will rise to around 1000 to 1100 amps. When this amperage has been reached, the independent brake cylinder pressure is to be reduced to 140 kilopascals. After this reduction in brake cylinder pressure, the traction motor amperage will reduce to approximately 650 to 700 amps due to the wheel creep system reducing power. You may need to increase brake cylinder pressure slightly to ensure that traction motor amperage remains constant at a minimum of 600 amps and to prevent the train rolling backwards. The brake cylinder pressure can now be slowly reduced to approximately 80 kilopascals, providing the traction motor amperage remains constant. Leave the throttle in notch 6 at all times during these movements. The wheel creep system now enables the locomotive to start moving. At approximately 3 to 4 kilometres an hour, reduce the brake cylinder pressure to 0. When the speed has reached 4 to 5 kilometres an hour, place the throttle in notch 8 to power up to normal operating speed. In this demonstration, Mark is following the same procedures as before, however he did not manually sand the track while bringing the train to a standstill. His attempt to start the train on this particular heavy grade is not successful, and the locomotive is unable to maintain traction. The end result is that the weight of the train is now the greater force, and the train rolls backwards down the hill. That brings us to the end of this instructional video, and as I mentioned at the beginning, the features Mark and I demonstrated are just a few that you are able to use to both save fuel and develop good train handling skills. Your off-job trainer will be able to answer any further questions you may have. Good luck.